Hi everyone! Today we are given a classic algebraic problem that looks simple at first glance but has a neat twist. We are given two equations involving A and B. One is A, difference of squares, and the other is the product of A and B. Our goal is to find A plus B. This problem is a fantastic example of how knowing the right algebraic identities can make solving equations much easier and more elegant. So whether you're brushing up for exams, love puzzles, or just want to see some neat math tricks in action, stick around. I'll take you through every step carefully so you won't only get the answer but understand exactly why it works. Let's get started. First, we recognize that a squared minus b squared is a classic difference of squares. This means we can offer it into two binomials. That's a minus b bracket a plus b. According to the problem, this product equals 16. To make things simpler, let's call a plus b by the letter s. That means a minus b must be equal to 16 divided by s, or 16 over s. So now, instead of two unknowns a and b, we have expressions involving just one variable s, which will make the rest of the problem easier to solve. Next, we will use a useful algebraic identity, the difference of squares for sums and difference, which states that a plus b squared minus a minus b squared equals to 4ab. Since we already identify a plus b as s and know that a minus b equals to 16 over s, we can substitute these into the identity. Then this gives us s squared minus 16 over s raised to the power of 2, which is equals to 4 times 4, because the problem tells us AB equals to 4. Simplify the right side, that's 16. This equation links s to itself in a way that it lets us solve for it directly. Now, let's simplify the equation we got. S squared minus 256 all over s squared equals to 16. To make this easier to solve, we want to get rid of the fraction. So we multiply every term by s squared, which clears the denominator. So multiplying through, we get s raised to the power of 4 minus 256 equals to 16 s raised to the power 2. Next, let's bring all terms to one side to set the equation to 0. So s raised to the power of 4 minus 16 s raised to the power of 2 minus 256 equals to 0. This is a quadratic equation in terms of s squared, which we can solve to find the value of s. To solve the quadratic equation, we simplify the process by letting x equals to s squared. This changes our equation to a standard quadratic form. X squared minus 16x minus 256 equals to 0. Next, we'll solve this quadratic using the discriminant method. This discriminant method is given by discriminant equals to minus 16 squared minus 4 times 1 times minus 256 equals to 256 plus 1024, which is equals to 1280. We rewrite 1280 as 256 times 5. So the square root becomes the square root of the discriminant equals to 16 root 5. Using the quadratic format, x equals to 16 plus or minus 16 root 5 all over 2, which is also equals to 8 plus or minus 8 root 5. These are our possible values of x, which, remember, is s squared. Next, we'll figure out which one fits our problem. Since x equals to s squared and any square must be a non-negative, we can't choose the value 8 minus 8 root 5 because the square root of 5 is greater than 2, which will make the expression negative. That means the only valid solution is x squared equals to 8 plus 8 root 5. We can factor out the 8 to make it a little neater. X squared equals to 8 bracket 1 plus root 5. Now we are ready to take the square root to find s, which is a plus b. Step 7. Now to find s, which is a plus b, we take the square root of both sides. So s equals to plus or minus the square root of a bracket 1 plus root 5. We can simplify this step by step. First, split the square root. So we split that, which is the square root of 8 bracket 1 plus 1 equals to the square root of 4 times 2 bracket 1 plus root 5. The square root of 4 is 2. So we bring that out. So s equals to plus or minus 2 root 2 bracket 1 plus root 5. We can simplify even further by noticing that 2 equals to 4 over 2, which let us write it as s equals to plus or minus 4 bracket 1 plus root 5 all over 2. So the exact value of a plus b is plus or minus 1, 4 root 1 plus root 5 all over 2. And there we have it. The exact value of a plus b is plus or minus 4 root 1 plus root 5 over 2. This neat expression is actually related to the golden ratio, which is why root 5 appears in the answer. If we take the positive case, we get approximately 5.0881, a beautiful finish to a problem that started with just two simple equations. Thank you for watching. Kindly subscribe to my YouTube channel. Bye.